let's see what they actually want me to implement. So they are saying that a user will provide me a list of domains, minimum 10 and maximum 100. For example, Amazon.in, Flipkart.in and Myntra.in, and my crawler has to crawl all the respective URLs of particular domain and return all the product URLs. I have taken an example here, example 1. So if after crawling example 1, I have to return all the product URLs. For example, example1.com/product123 and example1.com/product456. I think we are clear with the problem statement. Now let's see about the deep hierarchy. What do they mean by deep hierarchy? So let's take an example of Amazon.in. I have created a BFS tree for example. So let me take a pen. I'm ready with my pen. So see, let's say we are crawling Amazon.in and we starts from the home page. Let's say this is a root URL. This is a root URL, and this root URL, this root web page have 4 different URLs. We are assuming that Amazon.in home page, the root page have only 4 different URLs. So for the means of deep hierarchy crawling is that I will crawl first Amazon.in home page and then I will crawl the found URLs. I will start crawling this A, this B, this C and this D. And while crawling this A, B, C, D, I will again get these URLs inside each of the pages. Then I have to again start crawling for this, and this can go very deep because Amazon.in have a very huge number of products on their website. So for controlling this deep hierarchy URLs, I have implemented a max depth. So what does this max depth do is this max depth controls the deep hierarchy crawling, which means which means that let's assume that Amazon.in is at depth 0. I'm calling it D0, and after crawling Amazon.in root URL, I get A, B, C, D pages, A, B, C, D URLs, and let's call it D1, depth 1. And after crawling the depth 1 again, I will get all the URLs at depth 2. So with the help of max depth, I can define that you only have to visit only the depth 1 URLs, don't visit the depth 2 URLs. So we can avoid infinite loops. We can avoid infinite loops here. Start with the system design now. So what is happening here? User is giving us list of domains and I am parsing the list of domains and figuring out which of these are valid domains and invalid domains. So with the help of controller, I am adding valid domains into our queue with a specific domain job ID, and this job ID is written back to the user so that it can get the product URLs back. And the items, the domains added in our valid domain queue is processed by our worker, and this worker is first upserting domain into our domain database. And why this is a upsert domain? Because I want this operation to be atomic so that I can avoid race condition, because multiple workers can spawn here for same domain or multiple jobs can spawn here for same domain. So so avoiding the race condition, I am making this operation atomic. So after upserting domain into the database with the job ID, what I am doing is I am calling a method called crawl method, and this crawl method is returning us list of found URLs. This is found URLs. It means this have all the URLs found on the particular domain. I'm not then this found URL gets into a get product URL, and this product URL method is responsible for giving us the product URL. What this get product URL is doing, it is using Google AI, and Google AI is using heuristic approach for finding all the product URLs between the found URLs. And sometime our Google AI can also go down, so I have implemented a rechecks as a fallback. So what they are doing is they are taking found URLs and returning product URLs, and this way I have implemented a feature for returning product URL for an e-commerce website, and this returned product URL is stored in a product URL DB. Now let me show you the domain DB and product URL DB schema for better understanding. So this product URL DB have the ID, the product URL, and the domain ID. This domain ID is a foreign key for the domain database, and the domain database have domain, job ID, and status. And status is telling us about the crawling status of domain, whether it is completed or it is pending or it is in progress. So I think we are clear with the worker work and get product URL. Let's go to crawl method. But before going to crawl method, I want to tell you about that here single worker is doing upsorting thing, the crawling thing, and the get product URL thing. And a single worker will cause us a single point of failure. So what we can do is we can implement here some extra workers which will process different thing for different purpose. We can implement it, but it's not implemented yet. Now let's get to the crawl method. So crawl method have two methods, static crawling and dynamic crawling. In dynamic crawling, in static crawling, what I'm doing is I'm making an HTTP request, and after HTTP request I'm parsing that request, generating a DOM, creating a DOM, and from that domain I am parsing all the href, and after parsing all the href I am adding it into a URL visit URL queue and the found URL queue. And this process repeats until we crawl all the deep hierarchies, and this way we found our found URLs. And in dynamic crawling, what I am doing is I am using a headless browser, and for that headless browser I have used Puppeteer. What is happening here? Here I am launching a browser. So inside dynamic crawling, we launch a browser, we visit a respective URL of which is inside our queue, and we wait until the network is idle or the DOM content is loaded. And after the DOM content is loaded or the network is idle for 100 to 200 milliseconds, I scroll the website with the help of Puppeteer and gather all the hrefs, store it in a visit URL queue and found URL queue. Then again scroll the web page until the scroll limit hits, and after the scroll limit hits or the page go to at its end, I stop crawling for that particular domain and visit into the queue and check if queue is empty or not. If queue is not empty, then I again start crawling